So to finish up this week's lectures, I'm going to talk about type 3, 4 hypersensitivities and then the hyposensitivities. So type 3 hypersensitivities typically occur to administration of vaccines. They're kind of similar to type 2 because they use IgG and IgM, but they're different because these are antigen-antibody complexes. So the antigen isn't attached to a cell, it's just floating freely in the serum or in the body. And then once the antibody combines with it, it settles in the tissues and that causes local inflammation. So here you can see antibody-antigen complexes. They settle in the tissues and then they cause their local inflammation. Depending on the location that the inflammation occurs, that's going to determine what type of allergic reaction it is, or autoimmune reaction. Type 4 hypersensitivities involve T cells. Results when T cells respond to antigens displayed on self-tissues or transplanted foreign tissues. So the TB skin test is an example of a type 4 hypersensitivity. You inject a component of Mycobacterium tuberculosis into the skin. It's known as PPD, or purified protein derivative. If your body has been exposed to tuberculosis, your T cells, your memory T cells, will start to mount an immune response against that PPD. And in that process, it will cause the skin to kind of form this little bump, and it'll change the color of the skin in the area. Plant oleoresins also involve these T cells, so contact dermatitis. Inflammatory cytokines damage the skin, leading to itching and blisters. So that's another example of type 4 hypersensitivity. Transplantation. So the genetic and biochemical basis for graft rejection lies in the type 4 hypersensitivity. So you have these MHC genes. Cells of each person can exhibit variability in the pattern of cell surface molecules. These MHC genes, or HLA class types, are different among different groups of people. You want to match a certain percentage of these in order to do a successful transplant. There's different types of grafts that exist. Autograft. Auto means self. So when we're talking about an autograft, that's talking about taking a tissue from a person and putting it on the same person. So, for example, some people want fuller lips. So they get fat taken out of their butts and injected into their lips. So they're literally kissing their own butts at that point. But that's an example of an autograft. But a more serious example of an autograft is my uncle. My uncle had a toothache. So he went to the doctor with this toothache, and the doctor started looking at it, noticed that it was kind of black around the area. My uncle smoked his entire life. He had been smoking for 20 years before he got diagnosed with this cancer. So the toothache ended up being bone cancer. The cancer was so extensive that it spread into his lymph nodes in his neck, into his throat, into the entire jawbone, and even to the lungs. So he had to have major surgery. In order to put him back together, they had to take a chunk of his femur out of his leg to reconstruct his jawbone. They had to reroute blood vessels in his body and do a lot of blood vessel grafting. So I'm going to show you a picture of my uncle after his surgery. So they took blood vessels from down here and put them up here. They took, I'm not going to show you his leg, but he had his whole leg cut open to remove part of the femur to reconstruct his jaw. And he had this jaw plate put in to also form a bridge here to kind of put him back together. So it was a very serious operation for him. Luckily, he survived, and he's been cancer-free for 15 years now, which is just amazing. But recently, he wanted to get that metal plate out of his chin because all of his tissue kind of grew back together and it was sticking out pretty obviously. So he had it removed and he gave it to me. So I have my uncle's metal plate from his chin in my desk drawer, which is kind of funny. I'll bring it to class sometime so you guys can see it. Isograft. Iso means similar. This can only happen between identical twins. So this is a transplant between identical twins. If you don't have an identical twin out there, you would never be able to have an isograft. Allografts are transplants between members of the same species. So if I were to donate my kidney to my mom, then that would be an allograft. Or if some dead person donates their corneas to another person, that's an allograft. A xenograft is transplant across different species. So xenografts happen today. We take pig or cow heart valves out of their hearts and put them into the person. They're trying to genetically engineer pigs now to express human antigens so that we can grow human organs in pigs, slaughter the pig, and then isolate the organs and put them into the person. Problem with this is one of the theories as to the big outbreak of the swine flu that happened not too many years ago. So swine flu, the H1N1 virus, there was a huge outbreak a few years back, and they think that this originated from labs that are genetically engineering pigs to express human antigen. So there's a flu that infects pigs and should only make pigs sick. But if you have pigs that express human antigens, now the flu can mutate, or the virus, can mutate to not only affect pigs, but also people. And that's one of the theories out there as to where that swine flu came from. Then you have graft versus host disease. In very large organs, sometimes the white blood cells that are in the organ get transplanted along with the organ. And those white blood cells can try to kill the new host. They're not very successful because there's not very many of them, but they can still cause some damage in the area. Autoimmunity is hypersensitivity to yourself. Autoimmune diseases, we used to think that the immune system all of a sudden turned on your own cells. Now we know that they're a little bit more complicated than that. It's not just a matter of your immune cells attacking yourself. There's something that's stimulating inflammation in an area, and the immune system is trying to mediate that inflammation, and in the process, increasing the amount of tissue damage that happens. So they can be systemic or organ-specific. Systemic is body-wide. Organ-specific is obviously only involving a particular organ. And I'm just going to go through very quickly some examples of autoimmunities. So systemic lupus erythematosus is a systemic disease that affects multiple organ systems and causes rash in multiple areas and arthritis. Rheumatoid arthritis, which is confined to the joints, usually in the hands and knees. Graves' disease is where there's inflammation of the thyroid, which leads to swelling and hyperproduction of thyroid hormones. Diabetes mellitus is the attack of the pancreas, which leads to an inability or decreased ability to produce insulin. Myasthenia gravis affects the acetylcholine receptors. So there's autoantibodies that kind of block the receptors for acetylcholine. Acetylcholine is supposed to stimulate the muscle contraction, but if it's blocked, then you have paralysis of the muscles. And multiple sclerosis affects the oligodendrocytes of the brain, so it decreases synaptic transmission by deteriorating the oligodendrocytes. They do repair themselves, but then the damage can happen again. So usually patients with MS have these periods of disease and remission, so they don't constantly have the disease, but certain cases get progressively worse to the point where the patient can no longer walk. So now we're going to switch gears to hyposensitivities. So hypo means that your immune system is not working enough. A primary disease is something that you're born with. So if you're born with no T cells or no B cells, like you're missing the stem cell lineage to produce lymphocytes, then that's a primary disease. A secondary disease is a disease that you acquire in your lifetime, like HIV is a secondary disease. So some of those include DeGeorge syndrome. DeGeorge syndrome is a defect in your thymus where T cells do not mature. Your cellular defenses are diminished and you are more susceptible to viral infections. You also have a decreased ability to produce the parathyroid hormone. Severe combined immunodeficiencies. So this is where you are completely lacking the lymphocyte stem cell in the bone marrow, so you do not have any B cells or T cells. This is a very dire situation, because if you go back to that scenario where someone in downtown Racine bumps into you and you're fighting them and then you try to call your cousin for backup, there's no cousins to call for backup. So people who end up getting these infections don't have a third line of defense. They die of those infections. A treatment for this is a stem cell transplant. So you take stem cells from the bone marrow out of one patient and put them into the bone marrow of a new patient. The problem with this is you can't always do that. So bone marrow transplants are not an option for every patient, and selecting the patients that it would be a good option for is a daunting task. So SIDS, the boy in the bubble scenario, he was born with no lymphocytes, no T or B cells. The extracellular pathogens grow unchecked and lead to death. So this guy had to live in a bubble and eventually received the bone marrow transplant. Secondary immunodeficiency diseases are caused by infection, organ disease, chemotherapy, radiation. So yes, chemotherapy and radiation definitely can decrease the number of white blood cells that you have. HIV we already talked about, but that leads to the development of AIDS or acquired immunodeficiency syndrome.